Welcome to Cosmic Compass, where together we navigate the vast universe and uncover the hidden stories of space. From planets and moons to the mysteries of cosmic phenomena, this channel is your guide to understanding the wonders beyond Earth. Each crater, star and galaxy holds a tale billions of years in the making. Let's explore these stories, ask questions and discover the science that shapes our cosmic neighbourhood. Wherever curiosity takes us, Cosmic Compass will be our guide. The moon may appear to us as a barren and lifeless world, but if we take a closer look, we find that its surface tells a much more dramatic story. Each scar, each crater is a silent witness to a violent past stretching back billions of years. Let's uncover these mysteries together, and perhaps you'll see our celestial neighbour in a completely new light. Since 2009, the Lunar Reconnaissance Orbiter, better known as the LRO, has been tirelessly mapping the moon in extraordinary detail. With high-resolution images from multiple angles, it has given humanity a perspective of the moon unlike anything before. In a previous exploration, we looked at the mountains of the lunar surface. Today, we turn our attention to some of the moon's most fascinating craters. Thanks to decades of surveying missions, every part of the moon has now been mapped. One of the most accessible tools for the public is called Quick Map, an online program where anyone can explore the data themselves. If you ever wanted to roam across the lunar surface from your computer, that is where you can begin. Let's zoom far out for a moment. On the far side of the moon lies one of the largest impact structures in the entire solar system, the South Pole Aitken Basin. At 2,500 kilometres across, it is so vast that it could swallow entire continents of Earth. In fact, this is where China's Chang'e Fowl mission successfully landed in 2019, and the LRO even managed to image its rover from space. But without a familiar object for comparison, judging the scale of these features can be surprisingly difficult. On Earth, we rely on trees, buildings, or even atmospheric haze to estimate distances. On the moon, none of that exists. Everything is stark shadowed and deceptive in scale. That is why we'll use visual references along the way to help put these alien landscapes into perspective. As we zoom back and notice something remarkable, no matter where you look, the moon's surface is covered with craters of every size. This tells us something important. The lunar surface is ancient. It has not been resurfaced by lava flows or tectonic activity for over 1 billion years. The last major volcanic eruption is thought to have occurred about 1.2 billion years ago. On the side of the moon that faces Earth, scientists estimate there are around 300,000 craters larger than 1 kilometre across. Millions more are smaller than that. The moon keeps every mark because it lacks an atmosphere. Every meteorite, no matter how small, collides directly with the surface. On Earth, by contrast, most meteors burn up as shooting stars long before reaching the ground. Imagine if every streak of light you see at night were instead a real impact. Our planet would look very different indeed. So how do we tell the age of these craters? One way is by their appearance. Younger craters often have sharp rims, bright rays of ejected material and well-defined shapes. Older ones, in contrast, appear smoother, darker and more eroded. But erosion on the moon works differently than on Earth. There is no wind or water. Instead, the surface slowly weathers under a constant bombardment of micrometeoroids and the relentless radiation from the sun. Over time, these effects dull the brightness of the soil, leaving old craters looking subdued and worn down. Let's explore some specific examples. Here we find a relatively fresh crater, just a few hundred meters across. Using the LRO's narrow-angle camera, we can see the fine details of its ejecta. Dust was blasted outward, while larger boulders rolled away, leaving trails behind them. The crater itself reveals freshly exposed material along its walls, though the low sun angle at the time the image was taken casts long shadows that obscure parts of its structure. Now compare this to an older crater nearby. Its surface is smoother and darker, its sharpness faded over time. Yet even here signs of other impacts can be seen. In one image, a large boulder lies halfway down the wall, having tumbled there from a distant explosion. These frozen moments remind us that the moon's surface is dynamic, even if changes happen on timescales of millions of years. But top-down views alone don't always capture the sense of depth. Fortunately, the LRO can also take oblique images. In one spectacular case, we see a crater about 21 kilometres wide. Trails of massive boulders mark their descent down the slopes. The crater's walls are bright and youthful, but the darker base hints at something more dramatic: rock that was melted by the impact, pooling like lava at the bottom before solidifying. Imagine the force required. The impactor here may have been 2 kilometres in diameter, striking the moon at a speed 10 times faster than a bullet. Another striking example is a crater 10 kilometres across with a raised rim. After the impact, molten rock flowed beyond its edge before solidifying, creating an elevated outline. Scattered ejecta can also be seen nearby, disturbing the surface and leaving patches of fresh material exposed. And sometimes impacts occur in unusual places. One crater formed directly into the wall of a larger crater, creating an odd but fascinating overlap. From above, it looks deceptively circular, but its true shape is more complex. Interestingly, this image was captured in true colour. Most LRO images are black and white to save bandwidth, but even these occasional glimpses of colour remind us of the moon's subtle variety. Not all craters behave as expected. Scientists have discovered a strange phenomenon: regions around young craters that cool much faster at night than the surrounding surface. The LRO carries an instrument called the Divine Iradiometer, which has mapped the moon's temperatures. It identified over 2,000 of these cold spots. They appear only around craters between 50 metres and 2.3 kilometres wide. Curiously, the cold regions themselves are often larger than the craters that cause them. By day they vanish, blending back into the surrounding landscape. At night they return, standing out on heat maps as blue patches amid the red. What causes them? The answer is still uncertain. It may be linked to differences in soil composition or the way regolith was disturbed by the impact. But as of now, this remains one of the moon's many unsolved mysteries. And it leaves us with the question: what would you guess is behind these cold spots? Before we conclude, let's travel southward to one of the most breathtaking sights on the moon. Near the lunar south pole, a crater lies, almost permanently in shadow. The sun never climbs high above the horizon here, so only the peaks catch its light. The result is a stunning contrast of black and white, a pattern reminiscent of the yin-yang symbol. It is hauntingly beautiful, and perhaps more important than any crater we've seen so far. Why? Because these polar craters are thought to contain millions of tons of water ice locked away in perpetual darkness. Water is more than just a resource for drinking. It can be split into oxygen for breathing and hydrogen for rocket fuel. If humanity is to build a permanent presence on the moon, this is where it will begin. No wonder the Artemis program has marked the lunar South Pole as a key target for future missions. And so we've taken a journey across the moon's craters, some ancient and eroded, others fresh and striking, and still others harbouring mysteries yet unsolved. These are not just scars on a lifeless world. They are records of cosmic history, chapters in a book written in stone. The next time you look at the moon, remember, every crater has a story of impact, of violence, of time itself, and together they tell us how our solar system has been shaped. If you've enjoyed this exploration, there is always more to discover. Science doesn't have to be dull, it can be a thrilling adventure, as long as we keep asking questions. Let's continue that journey together. Thank you for joining us on this journey through the universe. The cosmos is full of mysteries, some we can explain, and others that still challenge our imagination. but every question brings us closer to understanding our place among the stars. If you enjoyed this exploration, let's continue it together like this video. Subscribe to Cosmic Compass and share it with others who look up at the night sky with wonder. Until next time, keep looking up, keep asking questions, and let curiosity be your compass.